Okay, Wildcat, say 9.3 exponential base of e assignment tutorial. Question 1 of 16. Identify the key attributes of f of x equals e to the x, include the domain and range in set notation, and the end behavior in all intercepts. Okay, step 1, graph e to the x. So let's go and use a calculator for that. So I'm going to on, new document, add graph. The e button is right here, and then x. Press enter. Now you can see you have a horizontal asymptote at y equals 0. So let's graph that first. All right, let's see if we can find points to graph. All right, so we're going to press Control T, and 0, 1 is good. Let's see if we can find. So 0, 1's are good points so far. And let's see if we can find another one that's good. All right, so probably we're going to have to approximate, but 1, 2.7, and 2, 7.3. And again, you're just going to have to approximate those. All right, so we have those points graphed. We know that it follows along the asymptote, and it's going to go up and through these points. Okay, go ahead and finish up the graph. All right. Step 2, as x approaches negative infinity, f of x approaches 0. And as x approaches infinity, f of x approaches infinity. Step 3, the function does not have any x-intercepts, but has y-intercept of 1 because f of 0 equals e to the 0 equals 1. So the y-intercept of f of x equals e to the x is 0, 1. All right, let's move on to the next question. All right, question 2 of 16. Predict the effects of the primitives h, k, or a on the graph of the parent function f of x equals e to the x. Identify any changes of domain, range, or end behavior. When g of x equals f parentheses x minus 1/8, step 1, the graph is translated 1/8 units to the right. Step 2, there is no effect on the domain, range, or end behavior. All right, let's take a look at the next question. All right, question 3 of 16. Predict the effects of the primitives h, k, or a on the graph of the parent function f of x equals e to the x. Identify any changes of domain, range, or end behavior. G of x equals f of x minus 9 divided by 2. Step 1, the graph is translated down 9 divided by 2 units. Step 2, there is no effect on the domain or end behavior, but the range changes to y greater than negative 9 divided by 2. All right? Question 4 of 16. Predict the effects of the primitives h, k, or a on the graph of the parent function f of x equals e to the x. Identify any changes of domain, range, or end behavior. When g of x equals negative 1 divided by 5 times f of x, step 1, the graph is vertically compressed by a factor of 1/5, and the graph is reflected across the x-axis. Step 2, there is no effect on the domain, but the range changes to y such that negative infinity is less than y is less than 0. The end behavior as x approaches negative infinity does not change, but the end behavior as x approaches infinity changes from g of x approaches infinity to g of x approaches negative infinity. All right, question 5 of 16. Predict the effects of the primitives h, k, or a on the graph of the parent function f of x equals e to the x. Identify any changes of domain, range, or end behavior. When g of x equals 21 divided by 2 times f of x, step 1, the graph is vertically stretched by 21 divided by 2. Step 2, there is no effect on the domain, range, or end behavior. All right. Question 6 of 16. Graph the function g of x equals e to the x minus 1 plus 4. State the horizontal asymptote, domain, and range. Step 1. Graph g of x equals e to the x minus 1 plus 4. Okay, so we're going to use our calculator for that. So I'm going to go to on, new document, no, add graph. So I have e to the x minus 1 plus 4. Now I'm going to move this out of the way. I'm going to go to menu, view, grid, line grid. Now I can see we have an asymptote at 1, 2, 3, 4. So y equals 4. Okay, so let's go ahead and graph that first. Okay, all right, so now let's find points to graph. Okay, I'm going to press Control T, and those don't look any good. 1, 5 looks like a good point. Okay, we could probably use the y-intercept. Let's use that 0, 4.36. All right, looks like we're just going to have to use 2, 6.7. And that should be enough points. Okay, all right. So we know, again, follows along the asymptote and goes up through those points. Okay. All right, go ahead and finish up the graph. All right, the horizontal asymptote is y equals 4. The domain is x such that negative infinity is less than x less than infinity. Step 4, the range is y such that y is greater than 4. All right. Question 7 of 16. Graph the function g of x equals negative e to the x plus 1 minus 3. State the horizontal asymptote, domain, and range. So let's graph that. Oh, almost forgot. Negative e to the x plus 1 minus 3. We're going to go to menu, view, grid, line grid. I'm going to move this out of the way. We can see how I have some at negative 1, negative 2, negative 3. So we have an asymptote at negative 3. Okay, so there's your asymptote at y equals negative 3. All right, so now let's press Control T and let's look for points. All right, so those aren't going to be good. 1, negative 4 is a good point. Or I'm sorry, negative 1, negative 4. 0, negative 5.7 is going to have to do. And then 1, negative 10.3. So all right. So we know it follows along the asymptote, goes through the points. It's weird. So I have to work that out. All right, go ahead and finish up the graph. All right, the Step 2, the horizontal asymptote is y equals negative 3. Step 3, the domain is x such that negative infinity is less than x less than infinity. Step 4, the range is y such that y is less than negative 3. All right. All right, question 8 of 16. Graph f g of x equals 1/4 e to the x plus 3 plus 2. Okay, so on new document, no, add graph, and we have 1 divided by 4. And actually, I would actually press Control divide 1 divided by 4. Click to the right, e to the x plus 3 plus 2. Okay, I'm going to move this out of the way. I'm going to go to Menu, View, Grid, Line Grid. So it looks like we have an asymptote at 1, 2. So y equals 2. So let's graph that first. All right, now let's go ahead and get some points. So I'm going to press Control T. Those aren't going to work. Negative 3, 2.25. That works. Let's see. Negative 2, 2.67. Negative 1, 3.8. And that's probably going to have to do for our points. So follow along here. All right, there's your graph. All right. Step 2. The horizontal is y equals 2. Step 3. The domain is x such that negative infinity is less than x less than infinity. Step 4. The range is y such that y is greater than 2. All right. Question 9 of 16. Graph the function g of x equals negative 3 divided by 5 e to the x plus 2 minus 4. So let's go ahead and do that. So on new document, no, add graph. So we have Control divide negative 3 divided by 5 e to the x plus 2 minus 4. Again, I'm going to move this out of the way. We're going to go to Menu, View, Grid, Line Grid. It looks like we have an asymptote at negative 1, negative 2, negative 3, negative 4. Okay. All right. So now let's graph. So I'm going to press Control T. And let's see. Those aren't going to be good. Negative 2, negative 4.6 is going to work. Negative 1, 5.6 will have to work. And 0, negative 8.43 will have to work. All right, so when you don't have no whole numbers, you're just going to have to use the decimals that you have. All right, so we know the graph falls along the asymptotes, or I should say asymptote, and it goes to the points. All right. Step 2, the horizontal asymptote is y equals negative 4. Step 3, the domain is x such that negative infinity is less than x less than infinity. Step 4, the range is y such that y is less than negative 4. All right, I want to finish up that question. All right, question 10 of 16. Graph the function g of x equals 3 divided by 2 e to the x minus 1 minus 3. state the horizontal asymptote domain and range. So let's go ahead and graph that first. So again, I'm going to go to on, new document, no, add graph, control, divide 3 divided by 2, click to the right, e to the x minus 1, click to the right, minus 3, move this out of the way, menu, view, grid, line grid. It looks like we have an asymptote at -1, -2, -3. All right, so let's graph that now. All right, now let's find points to graph. Press Control T. Those are going to work. -1, -2.7. That can work. 0, -2.4. 1, -1.5. 2, 1.38. I think the 2, 1 can be our last point that we need. All right, so there's our points. So follow along the asymptote. Go through the points and up. All right, go ahead and finish up your graph. All right, step 2, the horizontal asymptote is y equals -3. Step 3, the domain is x such that -infinity is less than x less than infinity. Step 4, the range is y such that y is greater than -3. All right, let's take a look at the next question. Question 11-16. Graph the function g of x equals -5 divided by 3 e to the x minus 4 plus 4. State the horizontal asymptote domain and range. So let's go ahead and graph that. So on, new document, no, add graph. So control, divide, -5 divided by 3, click to the right, e to the x minus 4 plus 4. Move this out of the way. Menu, view, grid, line grid. It looks like we have an asymptote. Oh, now I accidentally grabbed the screen. I'm going to click out. I'm going to go to menu, window zoom, zoom standard. Gets me back to the standard window, okay? So I can see I have an asymptote at 1, 2, 3, 4. So y equals 4. So let's graph that now. All right, now let's graph points. Okay, so press Control T. All right, those aren't going to work. That might have to work. 0, 3.9. 1, 3.91. 2, 3.7. 3, 3.8. 4, 2.3. 5, -0.5. And 6, -8.31. Again, when you don't have whole numbers, you just kind of have to approximate the best you can with the points you have. Okay, so we know that it follows along the asymptote, goes through the points, and down. All right, go ahead and update your graph. All right. Step 2, the horizontal estimate is y equals 4. Step 3, the domain is x such that negative infinity is less than x less than infinity. Step 4, the range is y such that y is less than 4. All right. All right. Question 12 of 16. Enter the function whose graph is shown. State the domain and range in set notation. So you have the point -1, comma 5e plus 3 and negative 2.8. And the asymptote y equals 3. Okay. Step 1. Use a reference point -1, 5e plus 3 to find the values for a, h, and k. All right. Now, we know that -1 equals 1 plus h. So we solve for h, so we subtract 1 from both sides. So we know that -2 equals h. Okay. Now we know that 5e plus 3 equals ae plus k. That means a is 5 and k is 3. Okay. Now, step 2, write the function g of x equals ae to the x minus h plus k, given the values of a equals 5, h equals -2, and k equals 3. So g of x equals 5e to the x minus -2 plus 3. Well, we know when you subtract a negative, that becomes a positive, so that's x plus 2. Step 3, the domain of g of x is x such that negative infinity is less than x less than infinity. Step 4, the range of g of x is y such that y is greater than 3. All right. Question 13 of 16. Example 5. Enter the function's graph is shown. State the domain and range in set notation. Okay, so we have an asymptote y equals 2. We have the point 4, -3, and 5, comma, -5e to the plus 2. Step 1. Use a reference point -1, comma, 5, -5e plus 3 to find the values for a, h, and k. So we know that, and actually that's a typo. That should say 5 right here. Okay. So we know that 5 equals 1 plus h. So to solve for h, we subtract 1 from both sides. So 5 minus 1 is 4 equals h. Okay. We know that 5e plus 2 equals, and that's, say 2. Okay. That should be all corrected now. So -5e plus 2 equals ae plus k. So a equals -5 and k equals 2. Okay. So I'm going to correct these values just to make sure. So we know that h equals 4. Okay. We know that a equals -5 and k equals 2. All right. So our equation is -5 e to the x minus 4 plus 2. Step 3, the domain of g of x is x such that negative infinity is less than x less than infinity. Step 4, the range of g of x is y such that y is less than 2. All right, question 14 of 16. Radioactive plutonium Pu minus 239 has a half-life of about 24,110 years. Use the function n of t equals n naught e to the negative 0.00029t to find out how many years it will take for 40 grams of Pu-239 to decay to 1 gram. N naught represents the initial amount of PU-239, and T is the time in years. Solve the problem using a graphing calculator. Round your answer to the nearest thousands. Okay, so that's important. To the nearest thousands. Okay, and I'll explain why that's important when you get to the answer. Okay. Then determine the growth rate or decay rate of the function. All right, step one. We're going to substitute n of t equals 1 and n naught equals 40 into the equation nt equals n naught e to the negative 0.00029 t. Okay, so n t is 1, n naught is 40. Okay, so now we're going to solve. Okay, so the first thing we're going to do is divide 40 by both sides. Well, 40 divided by 40 is 1. So we have 1 divided by 40 equals e to the negative 0.00029 t. Okay. Now the next step is we need to take ln of both sides. Okay. So we need to go to calculator. So on new document, no, add calculator. Now the reason we're going to take ln of both sides is I want you to see if I do ln of e to, let's just say 5. Oh, doesn't like that. Hold on. Oh, you know what? It didn't like my E. So give me a second. Let me pick the right E. So control ln. There's the right E. Okay. Now you'll see here that I just picked a random number, but ln and E cancel each other, so you're left with the exponent. Okay. So what that says is when you take ln of E, they cancel. So now we have ln of 1 divided by 40 equals negative 0.00029 t. Okay. Now we're going to divide that by both sides to solve for t. Well, anything divided by itself is 1, so this divides and becomes 1. So we're left with t equals, we need to put this in the calculator, okay? So let's do that. So I'm going to do control divide, control ln of control divide, lots of control divides, 1 divided by 40, divided by negative 0.1234429, enter. So we have t equals 127,203. Okay. Now, the radioactive plutonium will decay to 1 gram when, now we want to this to the nearest thousandth, so that's 127,000. Okay. So it takes approximately 127,000 years for it to decay. And the decay rate is R equals 0.00029 or 0.0029%. Okay? All right, so go and finish up question 14. All right, question 15 of 60. The population of the town was estimated to be about 7,200 in 1990 and grew at an exponential rate to about 40,000 in 2010. Use the exponential growth function P of t equals P naught e to the 0.086t, where P naught is the initial population, t is the time in years after 1990, and P of t is the population at time t. To determine after how many years the population will be at 60,000, solve the problem using a graphing calculator. Round your answer to the nearest whole number, and again, that's important, nearest whole number. Okay. Then determine the growth rate of the function. So we're going to substitute P of t equals 60,000 and P naught equals 7,200 into P of t equals P naught e to the 0.086t. Okay, so we have 60,000 for P of t and 7200 for p of naught. Now we're going to solve for t. Okay, so the first thing we're going to do is divide both sides by 7,200. Now we're going to see if this divides and becomes an easy number to work with. Otherwise, we're just going to leave that there. We know this divides and becomes 1. So now let's do control divide. 60,000 divided by 7,200. 25 divided by 3 reduces to be a nice number, so let's leave that as 25 divided by 3 equals, and it's not wrong, but I'm going to leave space for the exponent. So let me bring that number down to 1. So let me put the 25 divided by 3 here equals e to the 0.086t. Okay? Now we're going to take ln of both sides. Okay? Now we know that these cancel each other. So now we're left with L of n of 25 divided by 3 equals 0.086t. Okay, let's divide that by both sides. Now we know that this divides and becomes 1, so we're left with t equals that. So let's put that in the calculator. So control divide, control ln, control divide of 25 divided by 3 divided by 0.086 is 24.7. Okay. Now remember, we went to the nearest whole number, so the population of the town will grow to 60,000 when t equals 25. So it takes approximately 25 years. Okay. The decay rate is R equals 0.090 or 9%. All right, go ahead and finish up question 15. All right, and then for question 16, it's a great question, especially if you like coffee. But honestly, I recommend that if you need help with this question, use this step by step and follow through and use your steps. Okay. All right, so that should help you with the assignment. So with that, have a wonderful Wildcat day.